So today we're going to talk about surface area and volume. In this upcoming unit, we're going to find the surface area and volume of different three-dimensional shapes. So we want to look at what the differences are between these two words. Now, if we look carefully, surface area here, that's going to be the total area of all surfaces. So if I have a three-dimensional shape, I'm going to find the area of each of the sides and add them all together. And granted, each three-dimensional shape is going to have a different formula for that. When we write our answer, our units are going to be squared, so centimeters squared, just like when we found area of a two-dimensional figure. Now, here we want to look at key words that you see in word problems. I'm not just going to always say what is the surface area, so you may hear things like, oh, what is the outside area of something? So that's also surface area. Covers, so a good example of that is how much tarp I need to cover something. If I wanted to paint a box, okay, I'm only going to paint the surface area of it. To wrap, if I'm going to wrap something up, so say I need how much wrapping paper I'm going to need to wrap a present that I have. If I'm going to spray something, just similar to painting. And around, how much material I need to make something or cover something around. Okay, so all those words are very interchangeable. They all mean I want to do something to the surface area or the outside of my three-dimensional shape. Now, lateral area, you're going to hear that occasionally. So lateral area is area of everything except the bases. So in other words, if we look at this picture right here, the soup can, when the manufacturers make this label, they will use the lateral area, and that's because they don't need to cover the top of the tin and the bottom. They only need to cover this lateral right here around the soup can, because that's all the customer is going to see. They don't need a waste paper on the top and bottom. So that's called lateral, and we can think of that as the label of an object. So in this example, the soup can. Let's go ahead and look at volume. So looking at volume here, it's the amount of space inside the figure. So how much space is inside the three-dimensional figure, how much it occupies. So our units are going to be cubed when we write our answers. Keywords you want to look for and when they're asking is how much it's going to fills, holds, contains, full, half full, and capacity. So how much water can this cup hold? How much coffee can this mug hold? The pool is half full. So going to that example with half full, we can figure out, okay, well, using the dimensions of the three-dimensional pool, I can say, okay, find the volume and then take half of it because it's only half full. Please be aware that you will see things other than 1/2. You'll see a third full, maybe 4/5 full. Okay, and again, it's just asking, okay, if I were to fill it a third of the way or 2/3 of the way, okay? But that's still asking for volume, just a certain amount of that space, not the entire thing. Now, both surface area and volume are things that we can determine for 3D figures. Okay, so let's go ahead and look at nets. So nets of 3D figures. A net is a two-dimensional shape that can be folded from a three-dimensional shape. In other words, this three-dimensional figure is laid out flat, showing each face of the figure. So I took my 3D shape and just flattened it out. So think of it as a cardboard box, and you flatten it out completely. Okay, so here we also want to think about keeping the base of that shape and just taking down the sides to flatten it out. So like in that cardboard box, okay, making our rectangular base stay there and folding the sides down. Okay, and one thing you want to remember is the number of faces a three-dimensional figure has, it's going to still remain when it makes a 2D net. Okay, so before we can label all these nets, let's go ahead and look what these shapes A through G look like as a three-dimensional shape. So if we look here, I have a rectangular prism. So again, this is what that cardboard box would essentially look like. So here I have the top, the bottom, and the 4 sides. That would be my 6-sided rectangular prism. And again, if I were to fold that out, I'd have 6 parts of the net. Now the cube, it's very similar in properties to the rectangular prism. The difference is it's going to have the same length, width, and height. Okay, We have a cone. You can think of that as an ice cream cone with circular base here. Now, a square pyramid, it's called a square pyramid because the base of the pyramid is a square. Now, if we look at triangular pyramid, the difference is that instead of a square, I have a triangular base. I have a triangle as the base. Now, looking at cylinder, okay, I have a circle in the top and bottom as bases. Okay, so again, like that soup can. And then a triangular prism would have triangular bases. So you can see the front and the back here. And then rectangular sides. Okay, so these are what the three-dimensional shapes would look like. Now let's go ahead and just watch a video of these shapes being broken down into their nets. Now only some of these will be shown. So now go ahead and complete your practice here and identify each of these nets with the appropriate name. Once you have done that, please go ahead and check with the rest of the video. So go ahead and pause the video at this time to complete this practice. Now that you have finished the practice, let's go ahead and look over the answers. So the first one should be a triangular prism, the second one a rectangular prism, and the third one a cylinder. If we go ahead and look at the next row, number 4 would be a cube, number 5 a square pyramid, again it has that square as its base, number 6 would be a triangular pyramid because it's a triangle as its base instead of a square, and then 7 would be again a cylinder, 8 would be a cube, and 9 would be a cone. So if you look, some of these repeated, and that's because you can have different types of nets just folded down a little differently.